Okay, today we're going to be talking about multi-step equations. These are equations that require more than one step to solve. That is mind-blowing, I know. So, let's try an example to start with. 11x minus 4 equals 29. Remember, our goal is to always get x by itself. So, it's kind of like I do PEMDAS in reverse. I'm going to start with adding and subtracting things off. So here I'm subtracting 4. The inverse of that would be to add 4 to both sides. 29 plus 4 is 33. And on this side I was left with 11x. That's a one-step equation you can solve. You would divide both sides by 11. When I do that, these cancel. I get x. 33 divided by 11 is 3. We'll try one more. Let's do a plus 7 over 8 equals 5. Now remember that fraction bar acts like parentheses around this. So the first thing I actually need to do is get rid of this 8 in the denominator. So I'm going to multiply by 8 on both sides. These will cancel. I am left with that a plus 7 equals 40. Now I'm going to subtract the 7 off both sides. When I do that, I will get a is equal to 33. Okay. Go ahead and try this next one on your own. So we're going to go ahead and define some terms. The first term is consecutive integers. These are counting integers. So usually refer to those as like 1, 2, 3, 4, 5. But in algebra, sometimes remember we have that n. So then it would be n plus 1, n plus 2, n plus 3. So whatever we're starting with, whatever that n is, plus the next thing. If I talk about consecutive even integers, I'm not going to have that n plus 1. I'm going to skip right ahead to n plus 2, n plus 4. What if I talk about consecutive odd? Well, if you think about it, it's the same thing as the evens. Because if I start with 1, my next consecutive odd is 3, which means I added 2. So they are the same thing for odd and even. And this all plays a very important role in number theory. Number theory is the study of numbers and the relationships between them. Okay, so let's try an example of this. Let's say I have 3 consecutive, and I'm going to abbreviate, integers, and they sum to 21. So that means I'm going to take x, x plus 1, and x plus 2, and those are my consecutive integers. But remember it said the sum, so I'm going to add all those together and set that equal to 21. I'm going to go ahead and combine like terms. So I have 3 x's, and I have 1 plus 2 is 3. And now I have this multi-step equation. The first thing I need to do is subtract the 3 off both sides. These cancel. I have 3x equals 18. If I divide both sides by 3, I get x equals 6. That's great. That's not done though, because I had to look for all three consecutive integers. So I also need to know what x plus 1 is and x plus 2. Well, it becomes really easy. If the first one's 6, the next one's 7, and the next one is 8. Let's try another one. This time I'm going to say that the sum of 3 consecutive odd integers is negative 51. That kind of sounds odd, but let's go with it. Since I'm using odd integers, my first one will be x, my next one will be x plus 2, and my last one will be x plus 4. And again, I'm looking for the sum of those, so I'm adding them all up and putting them equal to negative 51. I'm going to combine like terms. I have 3 x's, so I have 3x. 2 and 4 is 6, and that is equal to negative 51. If I subtract 6 off both sides, I get 3x is equal to negative 57. I divide both sides by 3. 57 is divisible by 3. X would be negative 19. Again, I'm not done. I need to know x plus 2 and x plus 4. Go ahead and tell me what x plus 2 and x plus 4 is before you work the last problem of the night. And then we're going to be practicing with these more in class, specifically the ones with sums of consecutive integers. Have a good night.